Hey guys! So in this video we're going to review scientific notation. I know scientific notation is something that you should be using or should have used in the past. We just want to make sure that we understand the basics. So why do we use scientific notation? Traditionally we use standard form as the basic way to write a number. So the first example is 105. 3 digits, no decimal place, pretty easy. Second example, 0.0063. And the third example becomes this ginormous number that it's very difficult to A, name, or B, work with. So when numbers have lots of decimal places, they become more difficult to work with or type into a calculator or make sure that you're not dropping decimal places. So instead of using standard form, we now start using scientific notation. Scientific notation is a way of expressing very large or very small numbers more easily using a power of 10. So we have some decimal number times 10 raised to a power. In order to write a number in scientific notation, we need to know the following three things. The leading digit, which is the first or leftmost digit, it has to be a single non-zero number that will be left of the decimal. We need to know the order of magnitude, or the exponent used to show how many times the decimal should be moved left or right. And we need to know the sign of the order of magnitude. That tells us, are we moving left or right? So on this slide, I want to take a chance to look at a couple examples to identify the three most important things about scientific notation. So for this example, our leading digit is this 3. The order of magnitude is the number of decimal places we're moving, which given by this number here is also 3. And the direction of motion, since it's a positive 3, we are moving the decimal place 3 places to the right. So if we were to write this in standard notation, it would be a 3, a 6, and 2 zeros, so 3,600. Okay, so on these bottom two, we're going to identify the leading digit, the order of magnitude, and the direction of motion, and then we're going to rewrite them. So for this example, 7.8 times 10 to the 6th. Our leading digit is 7. Our order of magnitude is positive 6, so which means that we are moving the decimal place to the right again. So we have 7 and 8. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5 zeros. And that gives us 7,800,000 as our standard notation. This last example, our leading digit is our 6 and our 6.23. Our order of magnitude is 8 decimal places, and the direction of motion is to the left because it's a negative value. So now we're going to write 6, 2, 3, and we're moving the decimal this way. So one place moves it to the other side of the 6, which means that we need 7 zeros in front of that number. So 1, 2, 3, 4, 5, 6, 7. So if we count back, that's 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So that's a very small decimal. So on this slide, we're going to take our scientific notation and rewrite those into standard notation. So this first example is 5.3 times 10 to the 4. So we have the 5 and the 3. We're going to move the decimal 4 places, and since this number is positive, it's going to be 4 places to the right. So we started it here. We're going to go 1, 2, 3, 4. So that means that we are going to put 3 zeros behind that number, which is 53,000. This next example is the same. 9.24 times 10 to the positive 8. So we're moving the decimal place 8 places. So 9, 2, 4. That is a 2-move jump, so we're actually going to add 6 zeros to the end. So 1, 2, 3, 4, 5, 6. So we can put a comma here and here. So 924 million. Now this last example, 1.205 times 10 to the negative 5, we're moving the decimal 5 places, but we're going to be moving it to the left. So I'm going to write 1205. This is a single jump, so that means that I'm going to have 4 additional zeros in front of that 1. So that's a small decimal number. Now we're going to go standard back to scientific. So for this example, we need to determine where are we going to put the decimal place and then how many jumps and in which direction. So remember, we want a single leading digit. So this 6 should be our first number. 6.583 is the rest of that decimal, times 10, and we have to find what our order of magnitude is. So we are moving the decimal 1, 2, 3, 4, 5 spaces. And since we're going to need to make this number smaller to match this decimal, it should be negative. Now the next one, again, we need a single leading digit, so that's the 1, 1.456. The rest of these we can round based on how small it's going to be once we actually move the decimal place. So we're doing times 10, and we're moving it 3, 6, 9 decimal places. And then our last one, 568,340. We want a single leading digit, which is at 5, and we can leave the 6, 8, 3, 4, and we have to move the decimal place 1, 2, 3, 4, 5 places. So times 10 to the 5. So in this class, you're going to see numbers written in both forms, standard form and scientific notation. When we deal with molecules, we're going to have ridiculously high numbers of molecules. When we deal with masses or charge, we're going to have very small numbers. So we are going to have scientific notation to help us use those numbers a little bit more easily. Now, on this slide, I want to look at if any of these are written properly, and if not, we're going to adjust them. So this is the last thing we're going to be looking at for scientific notation. So if we look at this first example, what would we consider wrong about this example? It's 06.9 times 10 to the 3. This front 0 is unnecessary. So I would rewrite this as 6.9 times 10 to the 3 to get rid of that second leading digit. This next example, this is considered incorrect because of that base unit of 5. If this were written in proper form, it would be 9.7 times 10 to the 2. That 5 is considered incorrect. It has to be a base of 10. Now this last example, there are again 2 leading digits, 78.9 times 10 to the 4. So we would want to change that decimal place one more time, 7.89, and now instead of raising our power to the 4th, we have to add one more decimal place there to add it to the 5th. So when you work through some of your learning stations, you are going to look at scientific notation and standard notation. You're going to convert between the two, and you may have to do this step where you're identifying what is incorrect about that scientific notation. So if you have any questions, make sure you ask at the end of the video. Make sure you add your interactive learning log pages to your notebook when you are done taking notes on this section, just to highlight and summarize what you learned. And I will see you in class when you're ready to move on.